Okay, so for this problem, we have been given that there is a stepper motor with a 15-degree step angle, which is used to directly drive a 0.1 inch lead screw. I've made a schematic of this where I've taken a pi piece of the stepper motor, and I've shown you just two steps at a difference of 15 degrees, and this is connected to a lead screw, which would move axially by 0.1 inches when it moves 360 degrees or one revolution. That is what it means here by the 0.1 inch lead screw. That's kind of implied or a part of the definition there. And now we need to figure out what is a couple of different parameters. So let's start with part A. So what is the resolution of the stepper motor in steps per revolution? So the resolution here could be given by so we know what the angle is for each step, and we know that for an entire revolution we need to take 360 degrees. So the resolution would be 24 steps per revolution. Moving on to part B. What would be the distance the lead screw travels in inches for each 15-degree step of the stepper motor? So we now know how many steps comprise of one revolution, and we can use that information to convert the 0.1 inch per revolution definition that we have and evaluate what would be the distance traveled for just a 15-degree step. So the distance would be the 0.1 inch divided by the resolution, and here it's just multiplied by 1. Otherwise, if you had multiple steps, you can multiply it with the corresponding number of steps that have been given. So you would have 0.1 inch divided by or multiplied by 15 degrees by 360 degrees. So that's finally the expression that you evaluate, and that would give us 0.0042 inches. Moving on to part C. They're asking us now how many number of full 15-degree steps are required to move the lead screw and the stepper motor shaft to 17.5 revolutions. So to calculate the total number of steps, we have 17.5 revolutions that have been given to us, and we also know our resolution, which is 24 steps per revolution. So this will give us how many steps we would need for 17.5 revolutions, which turns out to be 420 steps. Moving on to part D. They're asking us what would be the shaft speed when the stepping frequency is 220 pulses per second. So the key point here to note is that the frequency is given as 220 pulses per second, which is basically corresponding to 220 steps per second. So each pulse causes the stepper motor to move by one step, and since there are 220 pulses every second, the stepper motor is going to take 220 steps every second. And using this, we can, so this is already an angular velocity, but we now need to convert it to the right units that we have been asked. So to convert it to RPM, steps per second, so I know I can convert seconds to minutes using that factor, and then we also know our resolution is given by that factor. So that way we finally have our answer as 550 RPM.